Hello everyone. Let us see the solution to the definition where we find the greatest common factor or the highest common factor. So for the two numbers x and y, right, I have created two text boxes here. So first thing, we would call the value from the text box into the variables and convert it into numbers. And the very first thing we would do is if either of them is not converted properly, then we are going to end up giving an error message. Otherwise, we'll find the greatest common divisor or the highest common factor. Now, what is the highest common factor or the greatest common divisor? Let's say there are two numbers, 12 and 18. So find out the factors of 12 and 18 and take the one which is the highest. So for 12, you will have 1, 2, 3, 4, and 6. And for 18, you will have 1, 2, 3, 6, and 9. Now, which one is common across both the factors, and the largest one is 6. So the answer for 12 and 18 is 6. And this is what we are going to do. So what we will do is we'll run a for loop, and in this for loop, we will go from 1 to up to the one which is the smallest. The first number or the second number may be the smallest. And I'm making an assumption that the user would surely enter two positive numbers and one of them would be smaller. So they are not same, and that they are integers. So this is my assumption. If you want to generalize the definition, you can go ahead and write in those extra lines of code to check whether it is an integer and then it is a positive number. But for now, let us make an assumption because we want to see how we can find the greatest common divisor. So what we will do is we will start with the digit 1 and we will divide these numbers by 1. If there is any remainder, we will switch to the next number. Otherwise, we will store this into the highest common factor variable. Then we will go to the next value 2 and try and divide this number by 2. And if there was a division possible, then we will store 2 in that highest common factor, replacing the previous value of 1. And this logic we will continue. So we will, at the end, our variable should contain the last number by which both these numbers were completely divisible. And that would be our highest common factor. So for this thing, let us have a variable, we'll call it as highest common factor, and let us start with the value 0. Now, if at the end of the entire logic, if the value of HCF is 0, then we will simply claim that there is no highest common factor. Now, 1 is a trivial factor, so we would not go with 1, but let us just assume that it is 0 and let us continue. Or we can actually take the value as 1. Okay, so let us start with I equals 1. We could have avoided 1. We really don't want 1 because 1 is a trivial factor. So you can actually start with 2, but I'll still go with 1. I less than equal to the first number is there in B1. So while I is less than B1 and I is also less than equal to B2. So when one of the number is reached, thereafter the condition would be false and it would stop the loop. So now here what we will do is we'll try and divide this number b1 and find the remainder of it by I. Now if the remainder is 0, that means b is completely divisible by I and b2, b1 and b2. So if b1 is completely divisible by I and b2 is also completely divisible by I, then we have reached a number which is common for both. So I'll just store I in this. So that's my entire for loop. Now outside the for loop, we can just go ahead and write the alert statement saying the highest common factor or the greatest common divisor is the value of HCF. So let us see, this is the entire logic for finding the common factor. All right, so let me put in the numbers 12 and 18 and see for myself if, yeah, I'm getting the value 6. So what if I entered 12 and 36? 12 should be the answer. So that's the answer. So if I put in 10 and 55, the answer would be 5. That's a common, greatest common factor. So it's working. Now, if at all you want to verify that the number should be positive and it should be integer, those things may be done here. And if the condition stands true, then this entire logic can be executed. Otherwise, an error may be generated. So you may go ahead and add in those additions, and I'll catch you in the next video with a new definition.